Okay, today we're going to keep talking about factoring, and we're going to try to factor some polynomials with higher degrees. You factored 1,000,000 quadratics, and you've even factored a cubic or two that happened to group, and the first two terms had something in common, and so did the second two. If this cubic shown here, it doesn't factor by grouping, so we need another way to factor cubics and higher degree polynomials. Here's the big idea for this topic. If a is a 0, then x minus a is a factor. Meaning if, let's say the number 2, if plugging 2 into this polynomial would give us a result of 0, then x minus 2 has to be a factor. So the easy way is to figure out what the zeros are and then turn them into factors. Okay, so here's that first polynomial graphed, 2x cubed and so on. Now we need to figure out what the zeros are. So let's zoom in on it just to get a little bit better picture. We need to see what these zeros are. Now my first two seem pretty obvious. It crosses at -2 and -1. And let's get that copied into the notes. So here's a good picture of it. So your calculator can confirm, but for the sake of time, we'll just go ahead and I'll just go ahead and tell you those are -2 and -1. So what that means is when you go to factor this polynomial, one of the factors will be x plus 2. Because -2 is a 0, x minus -2 or x plus 2 must be a factor. Same thing for x plus 1. All right, so we've got two linear factors. This is a cubic polynomial, which means we need one more linear factor. Now, just so we can practice finding that 0 one time, let's do second calc. I'm doing option 2, 0. I'm looking for this one that looks like it's between 0 and 1. Now, your left bound, you can use the cursor, or you can just type a number that you know is left of your 0. I'm going to do 0 and 1. So I'm guessing somewhere between those two little arrows. And I think it's about at 1/2, so I'm going to guess 0.5. I don't know that it's exactly 1/2, but then the calculator confirms that it is at 1/2. So 0.5 is another number that makes my polynomial 0. However, this a is 0, x minus a deal only works if a is an integer. My next factor is not x minus 1/2. That's where this one comes into play. If b over a is a 0, then ax minus b is a factor. So instead of this one, I need 2x minus 1. Okay, so if it's a fraction, and it's a nice neat fraction, a rational number like 1/3 or 2/5 or something like that, then 1/2 turns into 2x minus 1 according to this rule. So to factor, just to get it all in one good line, factoring that cubic goes like this. And you can multiply that back out to confirm, but that's going to be the factorization of that cubic. Okay, so this is the easy way. Let's do another one kind of easy. X cubed minus x squared minus 5x plus 2. So back to the calculator. I'm going to turn off for the first one and turn on the second one and see what my graph looks like. All right, I'm going to zoom out a little bit. I'm going to at least get my x over to about 4. Let's change my x max to 4, and that should show me all three of the zeros. All right, so I can see them all. It looks like I have a good one at -2. Value, let's see, at -2, I can try it that way just to confirm. At -2, I am in fact at 0. So I know one of my factors has to be x plus 2. So what about the other ones? Let's see where this second and third 0 exists. I'm going to go second calc. I don't have a suspicion about that second one. It's between 0 and 1, so I'm going to calculate a 0. I think, let's see, I know it's between 0 and 1, so my left bound is 0. My right bound is 1, and let's see, I think it's close to 0.4. It's a little bit left of center. So it turns out to be 0.381966601. Okay, so what does that mean? That means that it's not a rational root. It's not a whole number. It's not even a nice fraction. If it's going to be a nice rational fraction, it'll be obvious, like 0.33333 would be 1/3, and 0.4 would be 2/5, and so on. So I have one good rational root at -2, which I've made into x plus 2. My second one is not nice, and my third one, it's somewhere between 2 and 3. I'll just guess 2.5. It is 2.618034. Again, not a nice rational root. So here's an example of a cubic with one rational root, and I've got the factor. So how do I know what's left? When you factor, I need to know what else it's multiplied by. Well, if I told you that 2 is a factor of 100, and said what's left over, you would tell me 50 because you divided 100 by 2. Well, we need to divide our polynomial by the factor x plus 2. And we just got done talking about long division. I'm going to do synthetic to speed it up. And there we go. When I do synthetic division, my other factor is x squared minus 3x plus 1. All right, so I've found my one good factor, and I've divided it out to see what was left over. A couple things. This better be 0 every single time. If it's not 0, that means that x plus 2 does not divide in evenly. So either x plus 2 is not a factor, or you did your division wrong. Secondly, could I break this one down and find two linear factors? Think about that. You think this is going to factor and give me two linear factors. If you think about it for a while, you'll see that it does not. And if you think about why it doesn't, if it were going to factor and give me two nice, neat linear factors, then I would have seen two nice, neat zeros, rational zeros on my graph, which I did not. So when you see those irrational zeros, you should be expecting to end up with a quadratic as part of your answer. All right, so that's the easy way. Look at your calculator, find rational roots, and turn them into factors. The hard way. Let's factor this one, but without a calculator, all right? In case you're ever trapped somewhere and somebody will release you if you can factor without your calculator. All possibilities for the zeros are going to be a factor of 3 divided by a factor of 2. So the possible factors of 3, and it doesn't matter if it's -3 up here, because we're going to do plus and minus on our factors anyway. My factors of -3 are plus and minus 1, plus and minus 3. That's going to be the numerator of my 0, and the factors of 2, which are plus and minus 1 and plus and minus 2, are going to be the denominators. So all possibilities, I've got 4 on top, 4 on the bottom, which leaves me with a lot of possibilities. I could have plus 1 and minus 1. If I do the 1 over 1, I could have plus and minus 3. I could have plus and minus a half. I could have plus and minus 3/2. And did I cover them all? I've got 1 over 2, 1 over 1, 3 over 1, 3 over 2. So there are 8 possibilities for zeros of this polynomial. If I can find zeros, I can make them into factors. That's what I just did with my calculator. But this rational root theorem is what it's called, tells me what the possibilities even could be. And if I didn't have this graphing calculator, I would have to try to figure out which one of these was a 0. Now, unfortunately, that's going to involve some checking. So, it would be nice if plus 1 were a 0. So I'm going to check out plus 1. When you check plus 1, that just means plugging 1 into your polynomial and seeing if you get 0. So I do 2 times 1 cubed minus 1 squared minus 1 minus 3. 2 times 1 cubed, that would be 2 minus 1 minus 1 minus 3, which is definitely not 0. Let's see, what is that? -3. Therefore, a little triangle of dots means therefore. 1 is not a 0, which implies that x minus 1 is not a factor. So I would, at this point, have to keep checking, guessing and checking until I found the one. I'm going to kind of cheat and go to one that I know. And I'm going to check and pause and be right back with you. Okay, so I didn't want this video to be a half an hour long, so I went ahead and figured out what my 0 was. I'm going to check 3 over 2. Okay, so I'm going to plug in into my polynomial 3 over 2, and I get 2 times 3 over 2 squared, cubed, minus 3 halves squared, minus 3 halves, minus 3. So let's see, 3 halves cubed is 27 eighths times 2 is 27 fourths. Okay, 3 halves squared is 9 fourths. I'm going to go ahead and change 3 halves to 6 fourths because it looks like I'm going to be dealing with fourths. And minus 3, I'm going to make that 12 fourths. And sure enough, that is 0. So what that tells me, 3 halves is a 0, which I found by painfully checking all of my possible zeros, which tells me that 2x minus 3 is a factor. All right, we learned that on the previous page. If 3 over 2 is a 0, then 2x minus 3. b over a is a 0, ax minus b is a factor. So I used that rule and the fact that 3 over 2 is 0 to get my first factor of 2x minus 3. Now, luckily, you don't need to start going through and checking all of the other ones that you didn't get. Once you get one of them, now you can do division to figure out the other ones. Okay, so I'm going to divide 2x minus 3 into my original polynomial, and then I'll get, through long division, what's left over. So I'm going to divide that into 2x cubed minus x squared minus x minus 3. And the quadratic, again for the sake of time, do the long division for fun, but x squared plus x plus 1 is the quadratic that's left over. In this case, that quadratic may or may not factor. I don't have any graphical reason why it wouldn't, but this one does not factor. And if it did, you would end up showing some of those other 8 possible zeros. But this means my final answer, 2x minus 3, x squared plus x plus 1. All right, so that is this factored. All right, so these are some ways by finding zeros to factor higher degree polynomials. We've kind of been stuck at quadratic, second degree polynomials up until now. Now you can take any polynomial and find its zeros and factor it that way. The easy way, look for it on a picture. The not so easy way, do all possible zeros, which are the factors of your last constant and the factors of your leading coefficient, one over the other, and then checking until you find one. I'm going to show you one more thing. I'll just show you this on the calculator. If it's cubic, you should be looking for 3 roots. All right, so let's try cubic, and it looks like it might only have 2 roots. I'm going to put this one in factored form. I'm going to do x minus 4, x minus 4, and x plus 2. Now, I could have multiplied that all out and had x cubed plus blah, 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 x squared plus something x plus a number. But I wanted to put it in factored form just to make a point. When you graph this one, let's see what happens. Remember, factors are zeros. So I'm looking at my picture. I see -2 there, which means I have a factor of x plus 2. And then I see the graph bounce off at 4 and then turn around and go back through. This is what's called a repeated root. When you're trying to factor and the graph that you're looking at bounces off the axis and goes back, that's repeated, which is why the factored form of my, get rid of this ink, the factored form of my polynomial had x minus 4 in it twice. If it's repeated twice or 4 times or 6 times, it's going to bounce off the axis and go back the other way. If it's repeated 3 times or just once or 5, an odd number of times, it's going to go through the axis. So that's an example of a repeated root. So if you're doing this by calculator and you see a picture like this, that just tells you this factor is going to show up twice. All right, so we're going to call that a video. That is our fun time with factoring higher degree polynomials. I will see you in class. Remind me to tell you a good polynomial joke. Young out.